Right, this question is asking you to find the area of this shaded yellow bit here, but it's in between a line and a curve, so you have to think about how you're going to break this up. First of all, I can find the integral of this bit, which I'll colour in green, because it's above the axis. Well, we're not on that green, here we go, like that. So what I need to do is find how to get this integral. Because it's all under a curve, I'm going to be integrating this. I know it starts from 0 here, because it's on a straight line. I need to find that value. To find that value, I need to solve this equation equal to 0. Because when this equation here equals 0, it will give me this value, this value, this value, and this value, not that one, sorry, and this one. So these three values will be found when I solve that equal to 0. Because if I can find that, and I can integrate between here and here, it will give me the green section. So I need to find that, which means I'm solving this, x cubed minus 3x squared minus x plus 3 equals 0. It's a cubic, so there's no way of actually solving it without using something called the factor theorem or the remainder theorem. So what you look at is you think, right, I need to find a factor of this. To find the factor of this, I guess at factors of 3. Factors of 3 are either 1 or minus 1, and 3 or minus 3. So I substitute those in. So I'm going to try 1 and see what happens. So I'm going to put 1 cubed minus 3 times 1 squared minus 1 plus 3, which gives me 1 minus 3 minus 1 plus 3. So 1 take 3 plus 3 goes, so that actually does give me 0. So I happen to got lucky there. When I substituted in 1, meant I got 0, which means 1 works, so therefore a factor must have been x minus 1. Now I know x minus 1 is a factor, I can find the other two factors using polynomial division. So I'll get rid of that. And I'm going to divide this by x minus 1. So to do that, you see how many times x cubed, or how many times x fits into x cubed? That goes in x squared times. Then I say, right, I'm going to times the x squared by x, and times the x squared by minus 1 to give me minus 3x squared. Substitute my values, take them away. X cubed take x cubed is nothing. Minus 3 minus minus 3 is 0.
So
x squared. Minus 3 minus minus 3. I'll pause there, yeah.
X squared minus times a minus 1 and it'd be minus x squared.
Minus x squared, thank you, Lucy. There we go. Right, sorry. X squared times x is x cubed, x squared times minus 1 is minus x squared, and we continue. X cubed takes x cubed is nothing. Minus 3, take away minus 1 is adding. Minus 3, add 1 is minus 2x squared. How does x squared become minus 2x squared? We times by minus 2x. We then take it out and we do minus 2 times x, which is minus 2x squared, and minus 2 times minus 1, which is plus 2x. Bringing down the minus x from above and taking away. That's going to give me nothing. Minus 1 minus 2 is going to give me minus 3x. So then I'm going to have to see how many times x makes minus 3x, which is minus 3. And then I times minus 3 in here. Minus times minus is plus. Bring down the plus 3, so it gives me 0. So I knew it was going to give me 0 because I knew it's a factor, but it's left me with this. And if I solve this equal to 0, it'll give me the two other answers. So my two other answers, that looks like it factorises. It's going to be x and x. It's going to be minus 3 and plus 1. So this will factorise into there. So I know my three answers. One answer is x minus 1. So x equals 1 is one of those answers. This is going to be x equals 3. And this is going to be x equals minus 1. So these are my three answers. So this must be the minus 1. This must be the plus 1. And that must be the 3. So I found all those values. So there's quite a lot of work there from previous. We now need to integrate between 0 and 1 of this curve to find the green area. So I'm going to do that. The original curve was this, so I'm going to integrate that. Integrating this, increase the power by 1, divide by new power. Increase the power by 1 and divide by new power. The 3 cancels the other 3 out. This will give me minus x squared over 2, and that will give me plus 3x. I integrate that between 0 and 1. Now that's actually quite easy, because every single thing's got x in it, and I'm putting 0 in. So I know when I do my substitution, when I put 0 in, the second bracket is just going to be 0, because 0 goes into everything and gives me nothing. So I only have to put in 1. So putting in 1 is going to give me 1/4 minus 1 minus 1/2 plus 3. Then a bit of work with fractions. Minus 1 add 3 is 2, and 1/4 take 1/2 is minus 1/4. So it's going to be 2 minus 1/4, which is 1 3/4, which is 7 over 4. So this is just 7 over 4, which is this area. And we take away nothing. The next thing I need to do is find the area of this, remembering it's going to give me a negative answer when I do it. Now that shape here is actually formed of 2 separate shapes. So what I'm going to do is I'm going to drop a straight line down here and realise this is actually a trapezium, like that. So I can actually, don't use integration because it's going to be quite long and far to do it. I'm actually going to find the area of this trapezium, and separately I'm going to find the area of this little bit here. Okay? So doing that, the area of this trapezium, I know how far across it is, it's 1. I know how far down it is because I'm going to solve this equation here, where it crosses, and we know where it crosses at minus 7. So that's definitely minus 7. To find this value here, I happen to know this is when x is 1. So to find the y value, I'm going to put 1 in here. 2 times 1 is 2. Take 7, that's minus 5. So this value is minus 5. So if I was to sketch that out, I know that's 7, that's 5, that's 1. The formula for a trapezium is 1/2 a plus b, where they're the parallel sides, times the height. So 7 add 5 is 12, 1/2 of 12 is 6, times by 1, that area is 6. Now we need to find this little area here. Well, we've got a straight line and we've got a curve. If I integrate again the straight line, it's going to give me yet another trapezium in here. So what I'm actually going to do is going to find the area of the trapezium here. I'm then going to remove this very small curved bit, and I'll find that by integrating. Right, so doing this, put that back in. This little trapezium here, which I'll go over in red, that trapezium there, hopefully you can see that. We know the height of this side is the same as it was on the black one, so it's 5. The distance across here is 1, because this goes up to 2, therefore this is 2. So that's a distance of 1. And the height going up and down here is, if I put x is 2 into the straight line, 2 times 2 is 4, minus 7, that is a height of 3. So that's 3, and it joins up. Again, same formula. Add 5 and 3 is 8, half it is 4, times by 1, so that whole area there is 4. So I'm going to put 4 on this diagram. But I don't want all the area, I only want this little yellow sliver. So 4 is too much, I need to take away the purple bit. The purple bit I need to integrate, I will carry on. I'm going to integrate between 1 and 2 of the curve, because you see the purple bit is formed by the curve. Someone shut that door, please. So the curve, I'm going to integrate between 1 and 2 of all of this. That's a lot easier than you think, because you've already done it all up here, and even more, you've actually done the value of 1. So when I integrate 1 and 2, I'm going to get the answer, in square brackets, all of this again, which I'm going to write as x to the 4 over 4 minus x cubed minus x squared over 2 plus 3x between 1 and 2, knowing that when I do my substitution, when I put 1 in for the second bracket, it's the same as the answer was above, because it's the same question. So if I just move that back in, the answer to the first question was, I think it was 7 over 4, thank you. So this bit here was 7 over 4. This bit here, I therefore have to put 2 into all of this to get my answer out. So put 2 into that, it's going to give me 2 to the power of 4, which is 16 over 4, minus 8, minus 4 over 2, which is minus 2, and plus 6. 16 over 4 is 4, take 8, which is minus 4, take 2, which is minus 6, plus 6, so that actually becomes 0. But I'm taking away 7 over 4, so the area I get is negative 7 over 4. Negative makes sense because it's underneath the axis. So the area of the purple bit is negative 7 over 4. I knew the whole area of this was 4, therefore to find the area of just the yellow bit now, I do 4 minus 7 over 4. Change this into a fraction divisible by 4, which is 16 over 4 minus 7 over 4. 16 takes 7 is therefore 9 over 4. So the area of this here is 9 over 4, this bit. So I add all my answers together. The top answer, the green bit, was 7 over 4. This answer was 6. This answer was 9 over 4. I then add them together. This is going to be the same as 24 over 4. 7 over 4, add that, is going to give me 31, 40 over 4, is that right? Is that 9? Yeah, 40 over 4, which is actually going to give me a nice round answer of 10. So my answer to this, the whole area I started with, was 10.